Okay, so we're starting our second circuit. So we did digital to digital, so reading a digital value and following it and showing it in a digital form. So now what we'll do the other kind of signal, analog to analog. So what I'm planning on doing is reading a pot, going to a PWM LED. Okay. Oh, what did I write there? Oh, it doesn't like the. Let me see. There. Really? This stuff. Okay. All right. So you pull in Arduino. Okay. Those are PWM. Okay. 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 We need a pot that will clearly go here. Rotate. So Shift R. Okay. Put it that way. You'll see why. I know that my middle will be my input, my output rather. So whatever, A2 makes no difference. There's 6 that we can use, right? Well, actually, let's finish this guy. So the one side will go to the ground, and the other side will go to the 5 volts. An LED. Okay, here, resistor. Okay, go to the ground. I'm just being lazy right now. I'm just, using the simplest way to wire this stuff out. So that's why I'm using 13, but we could wire it wherever we wanted. That needs to be 250 ohms, so 0.25. That's approximate. It's okay if it's 200, 150 even. Right. Okay. Well, that's pretty much for our okay, code. Okay, so this one's going to be more involved, not by terrible amount, but more involved for sure. Okay, so I don't remember all of the syntax myself, so as I go, you're going to see like how even someone that knows how to do it operates. Okay, so I'll constantly check online. So how do we write this part, right? Because I don't do enough anyway. Someone that does that every day, of course, he wouldn't have to check, or she, but that's not my case, right? As much as I like it. So we need first to see, even now I'm having a doubt that, so pin 13 is definitely an output, so that's not a problem. Right. Okay, well, right away I need to go check an example. So examples are very useful. So you go online, read analog input Arduino. So it's already suggesting it to me here. Oh, I'm forgetting the work music. Okay, so we got this analog read. Okay, so this one's a bit involved. Okay, it's not obvious. Okay, so this is the Uno, right? If you look here, Uno, because there's different types of them. So this is the Uno. The range is 0 to 5 volts. We've got a 10 bits resolution. So what that means is how many numbers are you able to represent with that? So that's it here, 1024, right? So each bit that we increase, so essentially you get 1023, it's 1024, but it's 0 to 1023, right? Always 1 minus 1. So you got 1024 steps. So it's pretty good, right? You wouldn't want to use that for recording music because it's really, really low definition. But you still could. It'd be a bit, it wouldn't be very good though. But anyway, so you got 1,000 values from 0 volts. Because this is a sweeper here, right? So what that means is, as I'm going to rotate my pot here, my value is going to go from 0 to 5 volts. So if I pull a photo, just it'll be easier. Pot, read value. I'm just trying to show you an example. Images of a circuit. It's something like this. Voltage divider, maybe. Okay, so this is what it looks like. Okay, so you got your 5 volts at the top, you got your ground, and then your sweeper, which is your middle pin. This is what you read. And so you're going to exit here with between 0 and 5 volts, essentially, right? And that's why we're using analog here, because there's it's a range, right? So it's not digital. Okay, so the thing I need to confirm is, do I need to set up my input? So no, I don't, right? Because it goes in void setup here. It's not defined, so we're fine. Okay. So I don't need it. So easy enough for A2. But I need to see how we're going to read it. So this is how it's going to get read. I can copy the whole line. So it's analog read that goes here. Now they're using the value val, so let's use that for a variable. So we'll define an integer, right? So those are whole numbers, naturals. So let's call it val. It's always a good practice to define. In this case, it's not very important, but it's good practice. So integer val equals 0, right? And then as you enter the loop, we're going to read. So I don't like that. We'll just read from A2, right? That's what it says here. A2. See the number. And then what we'll do is we'll display that on the LED. But now, okay, so we're going to use another, we need to do another search. So that's PWM, Arduino out. Output, footage, blah, 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 that should work. So I just needed an example, also analog, right? So I didn't even remember it was called that way. Analog, right? Okay, very good. So on the Uno, it says I just have those pins, so that's important to remember that. So 11, so we might have to move our thing, right? So we do. So let's move this. No. Delete. Okay, are you kidding? Just want to delete it. Okay, how about I delete the resistor? What am I doing? going on? Why can't I delete it? Okay, is my keyboard flicking? Is it because I got code open? That makes no sense. It was. Okay, so let's go to 11. Okay. Okay, that's still working. Good to go. Okay, so 11. Let's go back. Analog right. This is the line I want. Here. Code. Got rid of the closing curlies. Copy. Paste. Oops, now I lost it. Right. Copy. Okay. So our LED is on 11. And now, the next thing we need to define is there some math that we need to do on our variable value? So I do not remember this. Let's check. Okay, so the duty cycle is, it's a quarter of it. So it's between 0 and 256. Let's just confirm. 256 times 4, does that give us 1024? It does, perfect. Okay, so that's why they had divide by 4. Okay, so good stuff to remember. Okay, well, that should work right away. I'm reading from A2. I'm writing 11, value 4. Let's just confirm. Okay, so some of you might be asking, okay, what's PWM? So PWM means pulse width modulation. Let's look at the, they should give us a drawing here. If not, yes. So essentially all we're doing is controlling the amount of time that it's staying on. But this is switching on and off very quickly. It's set on the other page here. So that's our frequency here. So pin 11. So it's basically 1 kilohertz. Oh, it's here, sorry. So it's 490 hertz, okay? Because I'm using 11. I'm not sure the Tinkercad simulation is taking that into consideration. That'd be a good test to check, but it makes no difference for us here. Right, so essentially this is happening, this space here, it's 1,000th of a second, because, no, sorry, in our case, it's 1/500th of a second here, right? Because it's 400-ish hertz, right? So, and then it just controls the amount of time it's staying on. So going full on here and then shutting down here. Okay. That should work. Let's give it a shot. Okay, so you see I'm at ground here, and then it should start to dim. Yeah, perfect. So you see, so basically now I'm at 5 volts, so the Arduino is reading that as being 100%. So now it's fully illuminated, and as I go down, we will see it starting to dim. Right? So the effect is you can see it, but it's not obvious because it's a simulation here. Okay, so even at the top end, we can see a difference here. Okay, so that does look like it's working fine. So why is that important? Well, because any kind of robot, it doesn't matter if it's robot or any kind of electronics around us, in cars, your phone, you've got two types of inputs to deal with, really, analog and digital. And you've got two kinds of outputs as well, so digital and analog. So so a speaker would be an analog output and so on. Okay, so that gives you an example here. Okay, so I'll ask you to practice those two, so that second circuit as well. Okay, all right, so that's it for this.